morning, good afternoon, good evening. Welcome back to chapter 34. We've been talking about ecosystems. In the last video, we had mentioned that the sun strikes the Earth with different intensity depending on where you are on the Earth. It strikes it more directly at the equator, and therefore it's a lot hotter the closer you get to the equator. It also means there's a lot more plant life. When the sun strikes the Earth, it imparts heat to the land, to the water. And it is important to understand that land heats and cools faster than water does. What that means is there's always wind at the coast. And the reason why there's always wind at the coast is as that hot air is rising, it's leaving a gap, it's leaving a void. So in the morning, when the sun comes up and the sun's shining down on the beach and the ocean, that hot air, the land heats faster, causing the air over the land to heat faster. That hot air then rises. When the hot air rises, cool air from the ocean moves in to take its place. In the evening, when the land cools, that cool air will descend. And when the cool air descends, the ocean water is still comparatively warmer, and so it's rising. So now the air is going to drop and blow offshore. The wind blows onshore in the afternoon. It blows offshore in the evening. The ocean is a continuous body of water. You've heard that people have sailed the 7 seas. You got the Atlantic Ocean, the Pacific Ocean, the Indian Ocean, the Arctic Ocean, the Antarctic Ocean. It's all just one piece of water. There's just one ocean. It's really big. There's just one ocean. It's all connected. Who is the explorer that sailed around the world? Magellan. Magellan sailed around the world without having to get off and walk because the ocean is one big body of water. Solar energy and wind energy drives the upper 10% of the water column, pushing a few things, actually, around the globe. It pushes moisture around the globe, moisture-laden air. Because water heats and cools very slowly, it pushes heat around the globe. And it pushes nutrients around the globe. The nutrients that get pushed, obviously, are nutrients within the water. And so these ocean currents push around, blow around a lot of stuff around the planet. This graphic shows these ocean currents. A couple things to note is the color of the line. The more orange it is means the warmer the water is, and the more faded it is, the cooler the water is. Again, here's that equator. We know that the equator is going to be where the warmest water is. The ocean is one continuous body of water. You can sail all the way around and never set foot on land. A couple things to keep in mind when we look at this graphic. This is showing where water tends to flow, how the waters in the Atlantic flows off that way, but then parts of it will curl back around. Notice all this curling right here? All that curling right there gives rise to the hurricanes that we get every year. One really good example of the ocean pushing around heat. This up here, obviously, is Canada. When you think of Canada, what comes to mind? You think of cold. You think of snow. If we follow this straight across, we come across into France, Germany, on into Russia over there. But what I want you to pay attention to is this area right here. These islands, this is Ireland and Great Britain. So this is the British Isles. This is specifically England. When you think of England, do you think of cold? Do you think of snow? You think of rain. You think of it being damp, cool, but you don't think of freezing, bitter cold. Look at its latitude. It is all the way up here, even with Canada. By rights, it should be frigid cold. Look what's right across from it. Scandinavia. This is Sweden and Norway. And when you think of Sweden and Norway, what do you think of? You think of really bitter cold. So why is England so different? The reason why England is so different is because of the heat that's being brought up by this North Atlantic current. This heat comes up, and notice how it takes a right turn right here as it hits England and Ireland. That's why they're not so cold. The latitude says they should be frigid cold. Why are they not frigid cold? Because of the warm temperatures that's being brought, the warm air that's being brought over with the water itself. The ocean is a really good temperer of temperatures. It evens out and smooths out these big temperature changes. Places on the coast tend not to get very hot or very cold very quickly. Why don't they do it very quickly? Because the water influences, the water reduces those temperature changes. Talking about air moving around the planet, talking about water moving around the planet, a mountain. A mountain is a physical barrier that air has to go over. So if we have a mountain, the air that's blowing around, and air moves around, the air that blows around hits that mountain, and then it has to travel up the mountain. What happens to the air as you go up? It gets cooler. What happens to this warm, moisture-laden air as it goes up higher into the atmosphere? What happens is the water vapor condenses, turns into clouds, and then rains. The water keeps going, not the water, excuse me, the air. The air keeps going up and over that mountain. But if all of the rain, if all of the water has fallen on this side, what is the opposite side of that mountain going to look like? It's going to be dry. It's going to be a dry desert. Why is it going to be a dry desert? Because all of the water that was in that air has fallen on this side of the mountain. That's referred to as the rain shadow. Warm, moisture-laden air moves on shore, bringing with it rain. As the water moves, it hits the mountain. The air has to be pushed up to go over the mountain. When it does, the clouds form, the water condenses, all of the water falls on this side of the mountain, called the windward side. The leeward side is the opposite side. Notice how it's not green over here, it's a desert. Why is it a desert? Because it doesn't get any rain. Why didn't it get any rain? Because all the water fell on this side of the mountain. Mountains are physical obstacles that the air has to go over. When the air goes over it, you have one side that gets all the water. You have another side that doesn't get any water. Rain shadow. The circulation of the ocean, the circulation of air in the atmosphere, the topography of the land give rise to the different ecosystems that we find around the world. These differences in climate, these differences in rainfall, these differences in geographic location influence what ecosystems we find. And the reason why we find certain ecosystems in certain areas has everything to do with its distance from the equator, its relationship to, or its relative distance from a mountain range, how close it is to an ocean, how close it is to a big body of water. All of these things influence why you find certain ecosystems in certain places. Yeah.